Hello, folks. Almost on mute there for a second. How embarrassing would that have been? Hello and welcome to this episode of the AI Show. We are on number 5. Ah! For those of us that were at Ignite, I welcome you. I try to sneak in a promo there at the end of the show. By the way, I am here to answer all of your questions, as are all of the guests. So please message us on all of the. We're trying to push to as many places as we can because we don't care how you watch, as long as you do. Thanks for being here. Today's episode is we've added an extra half hour. I keep running out of time to do the actual projects, which kind of stinks. Early at the top of the hour, we're going to have Luis, my friend, talk about Cognitive Search, a new feature released at Ignite, Semantic Search. Then we're going to do some work on the project, finally get back to our Rochambeau. Remember, we bought a domain name and everything for it. So we'll get to work on that as well. Also, at the top of next hour, we're going to have Suraj from the PyTorch team, because we finally got us a cool library segment that's going to be happening at the top of next hour. So I'm excited. There's a lot to talk about. So I am glad you're here. By the way, like I said, feel free to message us. I'm pretty excited about being here with all of you all. I know it's been a long week if you've been at Ignite. It feels kind of long to me, too. But again, this is for you, and I'm excited to be here. If you are on Learn TV, you just finished watching, hopefully, Hello World, a brand new show put on by my colleagues. I've caught in bits and pieces of it. It's pretty good. Make sure you tune into that. Okay, so it's time. It's time to go to the board here. Do this. I don't know what this is. What is this playing? I'm going to go to the next thing. That was weird. Okay. So again, to recap, we are going to start. I'm going to break this up into 4 segments, right? So the first segment is going to be all about semantic search. We're going to spend, I don't know, maybe a half hour there. The second segment, the sandwich, we're going to get to work on our Rochambeau stuff, all in PyTorch. Remember, we got to the part where we were building the actual models. I didn't get sick. I wore a mask when I was at Ignite, everybody. I wore a mask, except for when I was on the telly. But we had to stand really far away from each other. But I have to stand far away from everyone anyway, so... And I don't have a makeup person. That's why I look prettier at Ignite. Okay, now we're going to go to section 3. We're going to have the PyTorch folks. PyTorch 1.8, I think, came out last night. Maybe we'll ask Suraj about that. Plus another thing called LTB, and we'll figure what that is all about. I'm excited for this. I'm excited for this. And then we'll round out the last block with Rochambeau. Now, by the way, I haven't written this yet. This is not like a demo where I'm going to be like, and now let me press this hotkey, and then all of a sudden, like 50 lines of code come out. That's not what we're doing. We're actually going to code it up. And so I'm going to make mistakes, and I'm going to be doing a lot of Googling with Bing to figure out how to do this stuff. And then hopefully interspersed, and probably the most important part, are all of your questions. Like, you have any questions from Ignite? I'll give you whatever behind-the-scenes deets you want, because, like, it looks really fun from the outside, but it's actually a lot of work to do those shows. And it's not just, like, me and Donna and Christina and Joey and Caruana and Rick. There's, like, hundreds of people, like, working on this stuff. And literally, it's pretty cool. So if you have any questions about that, I'll take those. I know some people asked. I was at a user group yesterday, and they asked some stuff. So again, just remember, your questions are what is the most important for me. All right. Well, any questions to start? What do we got? Let me bring up Learn TV questions here. None in here yet. I do see Aishigul's here. Thank you, Aishigal, for coming. She's awesome. She's going to be in the back end, also answering some questions if I got that right. Ivana, the star of the show. She was on yesterday. No, 2 days. I can't even, like, these days are getting mixed up for me. She was actually on the Ignite show. We've got a famous person here. That's right. Pretty excited about that. Okay, so I guess we'll get started with the first block, and then hopefully we'll get to work here, and then I'm waiting for Suraj to show up. He'll show up sometime before 11, and then we'll get him on at the top of the hour, right up in here. And so now I can safely say that this piece of equipment was worth it. This is what it does. Oh, let me go like this. Isn't that cool? So I'm going to put this away because I don't think I need it anymore. And I think what we'll do is we'll bring on my good friend, Luis.
Hey, Seth.
How's it going, bud?
Good to be with you. It's always a pleasure.
I know. Well, it's good to be with you. So again, for those that don't know, and this is your first time here, we are actually filming like an official episode of the AI show. It's something that lives on Channel 9. And so Luis is super nice to come on here to like have you be part of our studio audience. Be part of our studio. So we may mess up. You are allowed to laugh at us as long as we do not hear. So, by the way, I was playing with my soundboard, Luis. Can you hear yourself, or do you just hear me? Like when you talk,
I hear you and I hear the sound. I don't hear echo, if that's what you're asking. Yeah, we're good.
Because I was messing with my soundboard the other day because I have one. I have a Zoom L8, and people were hearing themselves, and I figured out that my soundboard also transmits my computer sounds, which sometimes produces an echo. So I don't see it.
It's beautiful. No. It sounds
Microsoft
wonderful.
Developer is here. Oh no, the Channel 9 people. Now we're going to behave, everybody. So Luis and I have known each other now for what, a year and a half? We've been doing cognitive searchy type stuff.
Yeah. It's been fun.
So this is what we're going to do, Luis. Just a couple of tips. I'm going to turn the music off now so that we can be official. Let me turn the corner off here. Okay, that corner's off. So just a couple of tips. I know I've told you this before. So what I'm going to do is I'm going to be like, you're not going to miss this episode of the AI show where we're going to blah, blah, blah. And then I'll do the bumper, right? And then we'll be like, all right, welcome to this episode of the AI show where Luis is going to show us all about meaningful insights using semantic search. I'm practicing so that we don't mess it up, okay? Because then it's easier to edit. Tips for you, Luis. I know you know this because you're a genius. Let's share your screen first.
All right, let's share my screen real quick.
Let's just screen up. Let me
know when you can see it. There it is. You can see something there. We'll explain what that is later, but yes, you can see.
Let me add to the stream there. Okay, so it's working. Nobody look. This is the part. Nobody look. Shh. So that is working. Let me make sure that solo 1, solo 2, solo 3. Okay, the solos are working. Let me bring up my notes here. Notes. Okay. All right. And another tip, just look straight at the camera when you're okay, cool.
Sure.
Yeah. You're not looking at the camera right now. Which camera are you using?
I'm not looking. Am I looking at the camera? Oh, sorry, I was using a different camera. Oh, I see. Sorry, I have several cameras, so that's good to know.
Goodness. Are you gonna do like a 2-shot where you're like, and now let me show you like another shot?
Yeah, exactly. Yeah.
I thought I was professional.
Okay, now this camera works. That's perfect. Okay, sounds good.
I thought I was professional. I guess not. We have Luis here. And then when you run out of things to say, just stop talking. I know that I am the worst follower of that advice, but here we are. All right, so let me get my notes up here to make sure that I've got everything. Okay. Are you ready?
Ready. Let's do this.
Okay, so let me start. It's already recording because we're streaming this. Let me get ready with this thing here. Bumper. Okay. All right, here we go. All right, it's time to pay the bills. Here we go. You're not going to want to miss this episode of the AI show where Luis dives into something called semantic search. Way better than regular search. You're not going to want to miss it. Oh, I messed up the bumper. Dang it. I forgot to push the other button. Okay. All right, here we go. This is the good one. Okay, this is a good one. Here we go. You're not going to want to miss this episode of the AI show where Luis shows us all the new stuff in Azure Cognitive Search, specifically semantic search. Make sure you tune in. Hello and welcome to this episode of the AI show. We're going to learn all about semantic search. Let me bring this up here so you can see. Finding meaningful insights using semantic capabilities in Azure Cognitive Search. I got a special guest, Luis. Why don't you introduce yourself, my friend?
Thank you, Seth. It's a pleasure to be with you. So my name is Luis Cabrera. I am the Group Program Manager for Azure Cognitive Search. And I've been at Microsoft, like 17 years now. I went there right after college, and I've been having fun at Microsoft ever since.
That's awesome. So let's start first. For those that do not know about regular Azure Cognitive Search? Why don't we start with that particular question?
Yeah, that's a great question. So Azure Cognitive Search, think of it as, imagine that you're a developer and you want to create an application where you need to put a search bar out there to find content, whether it's documents or records. Maybe you're creating something for your human resources team, let's say, right? And it's a line of business application. It doesn't matter whether you're creating a web mobile application or a line of business enterprise application. If you have a search bar there, we can power that search with Azure Cognitive Search. It's a platform as a service component. You essentially point us to your information, or you push that information, we index it, then you can query it, and then, of course, we can give you the results, facets, filters. We have a bunch of bells and whistles that are interesting, including one that we're going to talk about today.
So let's move to that. So what's the difference between like semantic search and regular search? I want to understand more about this feature.
No, that's a great question. So with what you call regular search, or we may want to call it keyword search, let's say, right? You usually type some keywords, and then we have indexed your content so that we can quickly find where those keywords are in your content, right? So let's say you search for, I don't know, like let's say a product or something like that, or in Channel 9, right? Let's say in Channel 9, you are searching for the term machine learning, right? So we're going to go and find any place where the terms or keywords machine and learning, and we have language analyzers. So if somewhere else it says learn, let's say instead of learning, we're going to find those documents as well. So we have this, what we call an inverted index. So we can do this very, very quickly. Now, the catch is this. As people have been using search engines like Bing, they are getting used to doing very, very complex queries. So for instance, they may ask a query, how do I learn machine learning? Or how do I do this? Or who is Seth Juarez, right? So when they ask these very complex queries, those have meaning. And it's not about just finding the terms. Like, so imagine that someone is finding who is Seth Juarez, and there are a bunch of other documents that maybe the title of the document is who is Benito Juarez, right? Mm-hmm. That has who is and Juarez. It has three terms that are in common with the query, let's say, right? And maybe Juarez appears all over the place, but it's not the same meaning, right? You're not Benito Juarez, you're Seth Juarez.
That's right.
So how do we find the content that you need, even when maybe you're not using even the exact keywords? For instance, imagine I do a query like, maybe I'm going to a bookstore, and the query is how learn to cook French food, right? So what if the name of the book is called Mastering the Art of Paris Cuisine, right? So I am not using exactly the same words, yet I want to find that book. If there is another book that says how to learn French, even though it uses a lot of the similar terms, that's not the book I want. I want to learn to cook, not to learn a language, right? Mm-hmm. As an example. So this is the problem we're trying to solve. I have a diagram that I want to show you, just so that we can kind of get a little bit deeper into how this works. So we have this lexical ranker. This is what we have, and essentially most of the services out there that do search today, they're based on this type of technology, right? Like lexical rankers. And usually you have a query that goes through this, we find the documents, and then we give you the results. So in our case, sorry, let me put the focus in the right place. Let's say that I have a query. When was Walmart started, right? And I have a corpus of information. In this case, I am going to use a corpus that has 3.2 million documents. It's a big, complex corpus. It's very likely to have a bunch of documents that have similar terms to my query. And by the way, the MS Marco corpus is one that you can play with yourself. It's a publicly available corpus. So it's out there for data scientists to check how good their algorithms are for things like this. So then one of the new things that we added to our product recently, it's not part of Semantic specifically, but I wanted to introduce it here because it's part of the process, is a new spell corrector. So if I had mistyped the query, it will have corrected that before going to this lexical ranker. So let's actually run or give you an idea of what it looks like if I run this lexical ranker. So this is the type of documents that I get. Let me see. When I get like results like when was the WNBA started? When was CARICOM started? When was the Democratic and Republican Party started? So a bunch of documents in this corpus that have when was and started in the title. This one is interesting, right? When does Walmart open on Black Friday? It has the term Walmart. I imagine somewhere in there it may say things like Walmart starts its business hours at, 7 o'clock in the morning on Saturdays or something like that. But it's not what we need semantically. It turns out that the document that we want is actually in position number 10. So it's there. I mean, I will have found it if I had taken some time to go through all of them and maybe go to the next page in some cases, in some applications, depending on the size of the real estate of the search application. But some people don't have the patience for that. So how do we solve that problem? So we have partnered with Bing, who has developed deep neural network models to help us solve problems like this. They have invested literally millions of dollars and hundreds of dev years trying to solve exactly these types of problems. So we're one Microsoft, and we collaborated with them to use some of their deep learning models. So the first thing that we do is we have a new passage extraction model. Think of it as we take the top documents that are returned from our lexical ranker, such as the BM25 indexer that we have, and then we take those top documents and then we try to identify what are passages here that are representative for this document, right? So if I have a document about what artificial intelligence is, maybe we find a passage that says, oh, okay, so machine learning, is this or that, or deep neural networks mean this or that. So we identify a set of passages from each document. This is extraction, right? We're not generating this. We're actually extracting snippets of text or passages, right? And then we run them through a different model, which is this semantic ranker. So this model takes into consideration the query itself, each of the passages, and essentially is scoring how likely is this passage to be related to the query that was just provided. And then we go and resort the documents again and check this out. Which one is the top document? It is the document that was number 10 in our BM25 ranker before. Ta-da, right? So it came all the way to the top because it understands meaning. It understands that maybe somewhere in there, by the way, this is a pretty big document. It's about 22,000 words. Maybe somewhere in there it says something like Walmart was founded on a particular year or something like that. So it finds that passage, right? And therefore, this gets pulled to the top of the list.
I see. So if I'm understanding this right, and I want to make sure that I do, this is a search engine not for like Bing, but a search engine for my own stuff that I can set up. Is that right?
Absolutely. That's the innovation right here, right? So Bing already has, as I mentioned, invested in creating these models, and they have them in production today. When you go to bing.com, you're essentially using a lot of these models already. The part that is new is that in the past, I mean, they essentially were indexing the World Wide Web, right? And that was great if your content is in the World Wide Web. But what if you have, your own human resources application or a support ticket database that you want to index? Essentially, you want to find information in your own data or your own documents, right? Technical documents, for instance, right? We want you to find the content faster.
That's cool. And so basically that business junk drawer that we all call the share, we can send this service, point it at it, And then what it does, it narrows the search using the standard lexical stuff, but then it re-ranks them semantically. Am I getting this right?
You got it exactly, Seth. Exactly. And there is more. I wanna just kind of tell you one more thing.
I do.
So yes, we already solved the problem of ranking, but what if we could give you a little bit more?
Oh.
So imagine we already extracted passages that are important for each of the documents, right? So now we have another model that can extract which of these passages not only are related to the content, but may actually answer the question that you just asked. So by following this, we can actually extract just the passage, right? And in the passage here, it says headquarters in Benton.
You're saying this like too nicely and too fast. You're saying that if I ask a question, there's a second part of this customized search that will literally find the actual answer too.
Exactly. So we used to give you a list of documents. That was the outcome of Azure Cognitive Search. Now we don't only give you the list of documents, we give you an answer if we find it, of course, right? That will be essentially the passage that is most likely to answer the question that you just asked. And we go one step further, which is we actually can apply a highlighting model to that. So we actually highlight, in this case, the 1962 right here, right? That is within the passage, the elements of that passage that are the most important to answer your question. And we can apply the same capability, just like we extracted answers. We can show you the most relevant passage for each of the documents. And that's what we call captions. So we're super excited. I know that you said like, hey, you said this so casually. It's true, like I said it very casually, but literally we are taking hundreds of years of dev years, I guess, of development. We're taking a ton of investment that the Bing organization has done. We're taking it and making it available to you. Now, any Azure developer has these capabilities, very easily.
That's
we'll talk more about how to do it later. Yeah.
I feel like I want to see it in action. Do you have something you can show us to see it?
Absolutely. Yeah, absolutely. Let's do this. So you were just saying that you were at Ignite and you didn't contract COVID. So we're always worried nowadays, like, do I have COVID? Do I not have COVID? So the other day I had a problem. I had a sore throat essentially, and I was like, holy cow, do I have COVID? And I remember that we had just indexed a bunch of COVID data, for one of our demos. So I figured, okay, so like I'm gonna ask, what are the symptoms of COVID-19? So once again, we had just indexed a bunch of research papers and all kinds of content related to COVID. It's public data that is now available so that researchers can more quickly find answers and solve this problem that is affecting all of us, right? So let me ask this question. So right now what you see is the list of results that we will have returned with our normal BM25 index, this lexical index. So I am going to little by little turn on each of the features. So first I'm gonna fix spelling. I don't think I had too many or any spelling mistakes, but that did have a little bit of impact. I will add the semantic ranking and what? Okay, there we go. Some bug with my demo, and then so you can see that the results kind of got resorted based on that, but it's still like not super clear to me. Like there are the association between age, COVID-19 symptoms, and social distancing in the United States. It seems to be related. This one, an ophthalmological update. I'm not sure, right? So I'm gonna add answers and captions so that we can see how each of these documents matter. Check this out. By enabling answers and captions, I find the answer. The World Health Organization identifies fever, tiredness, dry cough, blah, 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 as common symptoms of COVID-19, and it says it lists other symptoms such as shortness of breath, aches and pains, and sore throat. Oh, shoot, that's not good, right? So maybe I have COVID, right? That was kind of scary when I saw sore throat in the list. So so I have the answers, I have the captions, and you can see how like it highlighted some of the areas that may be interesting to sort out, and it helps me kind of triage through the documents faster to see if I want to double click on them. So let's see. So the usual thing that I do if I have a sore throat myself is I just take some ibuprofen and I'm good, right? Like I don't usually get that much sore throat, but usually some ibuprofen or something like that lets me sleep at night and I'm good. But what if ibuprofen is bad if you have COVID? So let's ask another question. Let me see. So okay, so I see. By the way, I see that the World Health Organization is doing stuff. So I'm gonna say WHO for World Health Organization recommendation on ibuprofen. I'm gonna misspell ibuprofen by just because I want to show the speller in action. Let's see what happens. And let me see. Let me see ibuprofen. Did I not? I don't know what I'm doing wrong. But should I use ibuprofen?
Yes.
You think I should? Oh, the problem is I didn't say ibuprofen for COVID-19. Otherwise, I don't know if it's okay for COVID-19. Dun, dun, dun. Okay, so look, it says that the medical center in Israel, they monitor use of ibuprofen for a week prior to blah, 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 blah. So that may be an interesting document to look at, right? And by the way, you can see the speller work, right? So I'm going to use WHO as in, like, not WHO, but WHO was the first doctor that reported coronavirus. So different use of WHO. And check that out, right? So it understands when I do that, WHO doesn't stand for the World Health Organization anymore, but it tells me the answer. Dr. San Shishian is considered the first doctor to report novel coronavirus, right? So essentially, Seth, we're moving from just giving you results to using state-of-the-art deep neural networks to give you answers, to help you more quickly triage the records or documents that you care about, thanks to semantic search.
That's amazing. So I'm guessing that you probably have to set up an indexer and point it at something. I don't want to see that. What I'd like to see, if possible, is how do you use the service once you've set it up properly? Can you show us that?
Yeah, that's a great question. So our service is platform as a service. So essentially, you have a REST API that you use to query the service. So I'm gonna use an extension that is essentially hitting my service. I just have to tell it what the request is like.
Okay.
So this is a visual. By the way, I want to advertise it a little bit. It's a nice tool. It's this VS Code extension for Azure Cognitive Search. All I did is install the extension, select my service, go to a specific index, and then I can essentially make queries out of it. So I had this kind of document, this index based on oil and gas documents right here, and I just want to show you, like, this is what a simple query may be like keyword search essentially, right? So I'm going to click Control Alt and R at the same time. Oh, sorry, I think I have a typo in my JSON somewhere. Is that right? Do you see it right away? If not, okay, no. So I don't know what it was. So ignore this error here. So I did this query, and you can see that I get some results. These are some documents from the Society of Petroleum Engineers and so forth, right? That's great. I can learn about profiles, but I'm going to go one step further. I am going to change, add a few fields. Essentially, you can see the fields right here. Let me just zoom into them. I can essentially just specify the search fields. And the reason the search fields are important is because those are the fields that will be used to extract the snippets, essentially the passages, so that we can do the semantic ranking. Provide the language, because like different languages may have different semantic meaning given the query that I do. If I want to use a speller, I will specify the speller as well. And I can tell it if I want answers or not. In this case, I want extractive answers, and what fields I want to select, and so forth. I'm gonna do a harder query. I'm gonna use exactly the same, but I'm gonna say how to estimate injection profile, which is really what I wanted to know. So once again, I select this and then Control-Alt-R. And you see on the right, by the way, this is the JSON that comes back. Now we have this new component called search.answers, which is what was powering that answer that you were seeing in the other UI.
That's cool.
And what is really nice, I mean, I have the result injection profile was estimated, like some complex stuff that they were doing there, but it's giving me the answers. The results are now, if I look at the value of the results, now they have this re-ranker score, that this is the semantic score coming back and being resorted by this semantic score. And obviously I have the any captions or highlights that I may want for the particular document. So the key point here, Seth, is I didn't have to reindex any content. I didn't have to essentially spend hours reading the documents again. This is happening in real time. And if you have an index already, essentially you just change 4 lines of code, 5 lines of code, and magic happens, right? Now you have semantic answers, semantic captions, semantic ranking.
So if someone's already using Azure Cognitive Search and they've already pointed at their documents, they've got a really good indexer going, and there's an index that they have, literally they can just turn these things on if they want right now.
Yeah, exactly. With one caveat, which is this is a preview and it's a gated preview. So you have to fill a form to join the preview, and we will approve it. We're approving them. This is completely new, so we want to make sure that we have a way to connect with you you are trying this for the first time, and you provide us feedback at the very beginning.
So this is amazing. Where can people go to find out more?
Okay, so there is there are 2 links. Or the preview is aka.ms/semantic preview.
Okay.
And that will take you to the form that I was referring to, where you can essentially here. Let me just put it on the screen because
let's do that.
Let's do this. I think I have there you go. aka.ms semantic preview. Can you still see my screen, Seth?
Sure can.
Okay, perfect. So that is the most important link. I believe you also created an aka.ms/semantic that takes you to our Azure Cognitive Search Azure page, where you can learn about not only semantic search, but all the other features that we have to offer.
That is correct. Well, this has been amazing, Luis. And then make sure you look at the other camera.
Oh, this is the camera. Yeah, sorry about that. So I was probably looking that way most of the time. But hey, please try semantic preview. We're excited about it.
Awesome. Well, thanks so much for spending some time with us. And thanks so much for watching. We're learning all about, that's right, finding meaningful insights using semantic capabilities in Azure Cognitive Search. This has been another episode of the AI Show. Thank you so much for watching. And hopefully we will see you next time. Take care.
Thank you.
All righty. We did it.
You did great. Sorry, I was looking at the other camera. I'm so used to using my other camera because I use Teams and that's how it's set up. And so I was using my little camera instead. But that's okay. I think my face is not the important part of the show.
Your face is super important, Luis. Okay, so everyone watching, Luis agreed to stay after to answer your questions. So I think the most important thing is I've been seeing in the chat is people were saying that, oh, well, Bing is awesome. But you got to understand that this isn't Bing for searching the web. This is Bing for searching your documents. And not just text documents. It goes into PDFs. It can go into PowerPoints. Right? Am I right?
Yeah, exactly. Think of all the unstructured data that we have, right? Whether it's in blob storage or, or Azure Files or whatever you have it. Whether it's PDF, scan PDFs, with images inside of them, right? we have AI capabilities that can extract information from that as well, so that you can actually index it. We didn't talk a lot about that part of Azure Cognitive
We
Search.
have in other episodes.
But we do, exactly. We have talked about that in the past. Also, yeah, you remember we were indexing my mom's recipes, I think.
That's right. That's right.
That's what we did. So if you want to have some fun and check
and
that.
See that episode. It's a good one. I also did a talk on Azure Cognitive Search where we index like a bunch of pictures, and you're thinking, how do you put pictures in an inverted index? Well, there's these things called skills that you can put inside of the indexing pipeline to extract additional information using AI to put into the index. And now with semantic search over it, it can use that information to re-rank things as well, right? I mean, this is how this whole thing goes.
Exactly. So it's super exciting. So whether you have unstructured content like the one that Seth mentioned, or maybe you have semi-structured data in a Cosmos DB database, or completely structured in a SQL database, semantic search, this new capability that is part of Azure Cognitive Search, this platform as a service product, can help you index this information and give you the answers that you need, make you more efficient.
All right. By the way, here's from Jay here watching on YouTube. He says,
"Yay!
Org needs this." Yes, Jay.
Sign up for the preview, Jay. We want to give this to your org.
Yeah, like here, seriously, like there is so much information that an organization has that is going unused. Like every time I think I've invented a new thing, I always find someone that was doing something similar and that actually wrote it down.
Absolutely. I want to tie semantic search to my own email so that I can, just ask it questions and find information faster. Like essentially, anytime that you're searching, we want you to save time, right? We want you to find the answers as quickly as possible.
From Bill, speller is the tricky part. Yeah, that's the cool thing. Is this a new thing that spelling is going into the pipeline when we're searching?
Yeah, it's a new thing. And for now, just to give you an idea of what the reason that we started thinking of spelling is, right now, what we have is this kind of, like a normal speller, right? Like think of the speller that you would use in Office, essentially, right? It's just kind of finding misspelled words and fixing them. But that improves your what we call recall in terms of search, because we will find more documents if we have the correct spelling. In the future, what we would like to do is to use also neural networks for this type of thing, so that when you misspell something, it takes into consideration the rest of the words as well. And that's kind of what we want to do, but that will be coming in a future release at some point. Yeah.
That's cool. Like using AI to fix the things that we're doing is kind of cool. So this is awesome. All right. Well, any other questions coming on? By the way, there's some from Aishigul. She's putting up some helpful semantic search docs.
Hey.
There you go. What's new? She also did a talk at Ignite on what's new for cognitive services. So FYI. Well, this has been really fun, my friend, as always. I'm going to turn the music back on because we're done with the...
Always a pleasure, Seth. Thank you for inviting us.
All right, my friend. We'll see you soon. Take care, bud.
Thank you. Take care.
All right. He's a good dude, Luis. All right. So we have... It's now time for... And I have something for it. It's now time to do a little bit of work. So to do that, here, let me turn this music down here. Let's go to our Rochambeau thing. By the way, at the top of the hour, we're going to have Suraj come on to talk about PyTorch. So stay tuned for that. By the way, wasn't Luis cool? Wasn't that stuff cool? I remember the first, because I'll be honest with y'all. I was assigned to make a talk on Azure Cognitive Search, and I was like, oh, I want to build AI models. Oh, because sometimes we got to write talks for things that we just don't understand. And I remember like working with Luis. He's such a good dude. And I remember like all of a sudden understanding what it was and the practicality of it was so high that I was like, holy cow, everyone should know about this. And Pablo Castro, he's a distinguished engineer at Microsoft that works on it. Such a good dude. And it's good tech. It's good tech. And it actually solves some of the issues that we have, which is the best part, you know? Like I was working on it the other day, like I said, for my talk. And I was like, wait, you can add stuff to the metadata tree that gets indexed? And he was like, yes. I didn't do that sound effect at the right time. And I was like, holy cow, that is amazing. Oh, I pushed the wrong one, but it was still funny. So that's the cool. Jay McCormick is saying semantic search is awesome. Getting the answer the first time around is a huge bonus. Like imagine. Okay, let me just paint a picture for you all. Here, let me go to full, just me. Let me paint a picture for you all to give you a sense for what this actually means. Right? Let me go make sure I have the comments on. Imagine being like, how many days off do folks in this company get? And you know it's hidden in some HR document in a Word doc on page 6,552. And you know where the doc is, and you're like, ugh, I need to tell my significant other. I need to tell my husband or my wife or my partner how many days I get off, because we need to plan our vacation that hopefully we can do outside sometime the end of the year. How are you going to find that if it's buried in some doc on page 6,975, right? How does one actually do that? Well, with semantic search, you point your indexer, you point it directly at your files, and it will just index it. And if you turn on semantic search and you say, how many days off do I get? It will give you the answer. This is like having Bing, but for your junk drawer at your office. Seriously. Like, here, let me get a sound effect here. Here to just, I'm going to paint the story here. Let me paint the story. I want to know how many days I have off. Oh my goodness. But I can't find the doc. Oh, let me do another one. Let me do this. This is longer. How will I tell someone else? I can't find the page. Right? Man, I by the way, I was in theater, and so I can make myself fake cry. Did you see that? I was getting a little in there. Yeah. With semantic search, this isn't a problem. It will literally give you the answer. Yeah, I know. That was so dramatic, man. Whoa. I should be in theater. By the way, at the top of the hour, we have Suraj coming on to talk all about PyTorch. I believe they released a new version. We'll have to ask him. Let's see here. I think someone's saying something on Learn TV. Will it also search image alt or metadata drawn within the document's online search? That's a great question. No, it will do more than that. It will use cognitive services as a skill, inject it inside of the indexer, and then it will say, there's a giraffe in that picture. You don't even have to have metadata. It will pull that out, and then you're able to literally search for all the giraffes, and it will bring back the picture, the PDF, literally everything. It's pretty cool. That's a great question coming from Learn TV, by the way. If you're watching on Learn TV, aka.ms Learn TV. Most people don't know, but I wrote the first version of it. Did you know that? Don't tell anyone. But the production backend is written in Python. Because I got to choose. All right. Jay McCormick has a question here. Can you use it with Q&A Maker and a bot? You can do anything with a bot. Like, I like to think of the bot as the next gen like UI. Think about it. Like the bot is literally a text way to interact with a computer. And because it's a text way, it's pointing to some kind of serverless thing, you know? And then what you can do is you can literally call an API, and one of those APIs could be Azure Cognitive Search with semantic abilities. And so imagine having a bot for your internal documents. And here, let's get a sound effect here going here. Imagine having a bot internally where you can literally chat and be like, how much time do we get off in this company? And it's like 20 days. Yay! I was actually going for like a happier yay, but I couldn't find it. I know, right, Jay? Jay's like, nice. Indeed. Wow, this music is making me stressed out. Speaking of stressed out. All right. So let's get to it. I promised we would work on some stuff. And then again, in about 10 minutes, we're going to have Suraj come on to talk about PyTorch stuff. So he's pretty cool. They can't see you yet, Suraj. Suraj already got here because he's such a diligent person. Such a nice dude. All right, let's go to code dot. Oh, I didn't spell it right. Code dot. I feel a little self-conscious that the folks from PyTorch are here and they're looking at my PyTorch code, you know? All right, let's go over here. Conda, activate torch. Pow! And I think the last thing we did is we started training it. Someone in the chat is like, love the failed yays. Yay! I'm going to turn that up because I didn't think you hear it. Yay! I have a couple of other ones. I'm trying to fit them in. Like, here's one. Like, anytime I do my code, I should have someone go like this. Ooh. Yeah, PyTorch. Ooh. Indeed. All right, so here we are with our code. I think we went through it last time. Here's my training code, by the way. Incidentally, this is all available on GitHub. I wonder if my GPU is, like, my laptop is going to start to get super warm. It's already warm. When I train this thing. But you recall that the outputs we had are here. I saved them in both. Oh, you're not even looking at my screen. I'm such a goober. Here you go. You remember that here's our model here. Remember, we saved them each. And if you remember, let me just do a quick reminder that basically when you're building a PyTorch AI model, you're basically building a thing that will take a picture of me doing rock or paper or scissors or nothing, and then it will just out will come rock, paper, scissors, or nothing. Okay, so this model is like, think of it as a function that was learned instead of coded. I always said that last time. So let me show you what's in it. So let me go reveal in File Explorer. Here we go. Here we go. View. Let me take off the navigation pane here. Kapow. It's going to open on my main screen, isn't it? Netron. This is what's inside the model. Inside of the AI model, and you're like, that's why it's called deep learning. Yes. But the reality is, we don't know how deep it has to be deep learning. It really depends on the marketing department. I went there. Hold on. I should have done the gas faster. It really depends on the marketing department. Here, let me turn it up. I'll do it again. It really depends on the marketing department. Yeah. Thank you. That was my favorite joke of the day. But by the way, as the picture comes in, you can see that it literally knows, like, there's a picture. Oh, there you go. A picture looks like one at a time, right? 3. What does the number mean? Well, RGB. Oh, jeez. I can't even write today. It's Suraj. She's like in the back end, like secretly judging me. RGB. And so that's the 3 pixels, the 3 here. And then, by the way, every time you hear that bling, that means someone on Learn TV is telling me something. And then here's the height versus width. Height versus, by the way, you hear that, right? You hear the bling, bling, bling. Okay. Yeah. Okay. You hear that. So that's Learn TV. Let's see what they're saying on Learn TV. M365 developer. Oh, I'm trying to fit that in somehow. I didn't mean to push that. That was a complete accident. But anyways, notice that the picture comes in, and then there's some stuff that happens, right? So I trained the model. Let's go to the scoring file here. Oh, this is gonna bother. Is this gonna bother everyone watching? You know what I'm talking about, right? Like anytime there's like a update, like you feel it in your bones. I need to update. There's something in there that's gonna be so awesome. Okay, so here is the actual scoring thing. Another Learn TV, Unity. Wow, what are they saying? Like maybe people are like in the wrong show. I'm gonna turn that down so I don't look at it again. So basically, here is my scoring file, and my scoring file basically takes the model, right? If you're looking at this, is an artifact of Azure ML, and we'll talk about this probably next week. But here is the model. I'm using an Onyx format, just because it's to me it feels a little bit more portable. And PyTorch supports Onyx, natively. So, for example, when I save the file, when I save the model, you can see. Let me go over here. Go to definition. You can see, basically, I can say onyx.export blah, but you're probably wondering, where does that come from? Well, notice it's torch.onyx, right? So PyTorch natively supports Onyx, which is delicious. Think of Onyx as like the PDF for deep learning, right? That's why I can open it like this and do some. Incidentally, you can open PyTorch files too. For PyTorch, you can save the state dictionary and then rehydrate it, right? That's the way I like to think about it. So I save the model, but for scoring, basically, notice I'm loading the model up. Now you can see RT inference session. Hope this still works. I haven't tried this in a long time. And then what I do is I resize the picture, center crop. Remember 224 by 224. Normalize the pictures. And you're like, why are you doing all this stuff? Well, because that's how I trained it. Go down here. Notice that when I did the training, if people are lost, go into the chat and be like, Seth, I feel like you're skipping so many things, and I'll tell you what it is. But just I need to know from y'all, because I just assume everybody knows way more than I do. And so then when you score it, right, it does this transform on the picture, and then this is like a requests style thing. It basically loads the raw data, which is an image thing. Right now, it's doing this. This, and because this is from an old school. I used to do tacos and burritos, so we might have to change this a little bit to make it work on our pictures. But basically, notice that it's getting the image, right? And then it's transforming it, and then it's doing a prediction. So let's do this. Let's see if I can't. How am I going to get an image? I need to put one of these. I know what I'll do. I know what I'll do. So notice we have some data here. Let's go to the training, or maybe validation. Let me go to the training, and let me get like a rock one. And what I'll do, let's do this. Let me do a folder with eval. So new folder. I know what I'll do. Eval, because we want to see if our scoring stuff works here. And we have 3 minutes. Let's see if we can get done in 3 minutes. Before Suraj comes up. By the way, top of the hour, Suraj from PyTorch. Going to be talking about some cool stuff. So we want to go with the validation data set. Let's take a rock picture. Look at that. Who's that? Look at this beautiful picture. Let's put it up in here. And we'll rename this Rock. Pow. We'll take a paper. By the way, this model, I think, if I remember right, was the best one was like at 68%. We have to change the model type, I think. So we'll Control C with the paper. It would have been embarrassing if I was wearing the same shirt. We kind of got out of that somehow. Thank you, Seth, for thinking ahead past Seth paper. Okay, and now we need to find a way to make this web thingy. So let's do this. Let's do CD Rochambeau, boop, CD data, and then CD eval, right? And then Python -m HTTP. I think that's it. All right, this is where we have to go and look up the Python. Python web server. 3 lines to make a Python web server. Beep, 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 beep. Ooh, towards data science. Yeah. No, I don't want to do that. Oh, I know what I can do. Okay. What? Yes. So now what I can do is notice that this is like localhost 8000, localhost 8000, and then I can do like rock, for example. .png. Boom. Okay, so this works. So now what I'm going to do is I'm going to try to score this here. And instead of passing this thing, I am going to, let me close this, close this, close this, close this, close this. And we're going to go to the scoring file. And I'm going to pass in this thing, right? I think this is a rock, right? And then we'll take this out. And I will pass in the rock image. And then say inference with rock. And let's run it. Let's see what we got going on up in her. So I will press F5 and hope for the best here. Is it conda activate for me the right thing? Did it conda activate? Oh man, an error has occurred. Oh geez. NumPy. Do I even use NP anywhere? I don't think I do. Let's try again. No, that's not what I want to do. That's what broke it last time. Okay. So we're going to leave this be because it's the top of the hour, and I promised I would bring Suraj on. So let me unscreen this thing while it's doing it. Cool. So I know how to fix this now. So I have here with me today, my friends, Suraj.
Hey, Seth.
What's up, buddy?
It's going good. I like the sound effects that you have.
They're goofy, right?
They made me laugh multiple times, and I had to check I was on mute.
Yes! All right, friends, guess what? It's time for a cool library. All right. So record this. Like we were going to save a recording of this, so we got to be serious for a little bit too. Let me bring up my stuff. Here. Do you have a screen? Are you going to share your screen for this, Suraj?
I could.
It's up to you, man.
Tutorial.
You're in charge. Or I could share too. I mean, it's up to you, buddy.
Yeah, you can share it.
Okay. So let me move this over here. Okay. I think it's this. And let's go over here. This is this. And let's go to PyTorch.org. All right. So we're going to start this because for those that are watching, by the way, Suraj is awesome. So if you have any questions for him, make sure. But I think we're recording this so that they can save this too as an intro to this stuff. Is that right? I think so.
Yeah.
All right. So let's start. We're gonna start the same way we started before, but with a cool library. All right. This segment of the AI show, cool libraries. All right, Suraj, I thought you would introduce yourself. Tell us who you are and what you do, my friend.
Sure. My name is Suraj Subramanian. I am working at PyTorch as a developer advocate. And that means I speak to other developers who use PyTorch for their deep learning journey. And I like to try to understand what they're using PyTorch for and see how I can make that a little easier.
Fantastic. So let's start first with what is PyTorch? You give us a brief overview of what PyTorch is for those that don't know.
Yeah, PyTorch is it's an open source library that you can use to build and run deep learning models, similar to what you have been using for Rochambeau. If you're familiar with NumPy, PyTorch brings all of that scientific computing goodness onto hardware accelerators like GPUs and TPUs and all of that.
That's awesome. So why is PyTorch a good library to get started with when it comes to deep learning?
The primary reason is the API. PyTorch API is really simple, but it's also very powerful. It's Pythonic. So if you're familiar with programming in Python at all, you'll find yourself at home using PyTorch. Another really good reason to start with PyTorch is because it's easy to debug. So the dynamic nature of PyTorch really allows you to debug your code very easily. You can just plug in print statements just to keep track of what's happening in the code. It also helps you understand how neural networks work. It really helped me get a better intuition of what's happening under the hood inside a neural network. And
that's awesome. So where can people go? Like, if someone's like, I'm totally excited, I have the website just right over here. Where should people go to get started? By the way, you just had a 1.8 release. Is that correct?
Yes, we just released that yesterday.
Oh, see, timely. So let's talk about, if people want to get started, what's the best way to learn the basics?
To learn the basics, you head to the tutorials tab on the website.
Let's go there, right there.
And whoa, I mean,
it's
how mind-blowing is this? There's a section exactly titled that, Learn the Basics.
What? This is cool. So tell us about this.
So this is the 101 tutorial to PyTorch that Seth, Cassie, Dimitri, and Ari, and myself collaborated to build. It's a great way to get started with PyTorch because it's a very step-by-step guide to every single stage in the ML workflow, in a typical ML workflow. It starts with the very basics, tensors, which are the building blocks of basically everything in PyTorch. And it progresses sequentially into how to get your data prepared and load it into your model. How do you actually build a neural network? What's actually happening within the neural network when you click or when you run backward, which sets the training loop on, and it's and also how do you persist the neural network so that you can load it for later use.
I mean, this is really cool. I mean, I'm looking at this and I'm like self-servingly saying this is really cool, right? Because like we helped write it. But like the thing that I like about this is it comes at it from the sort of developer's perspective. It's really cool for me to look at this because it, like I said, it's it's fun and you could probably get through this. How long do you think it'll take for someone to get through this?
Probably. I wouldn't say it takes anything more than an hour.
Got it.
Even if you run all of the code in this, so it's a really quick way to get started.
So who is this for? Like, if for people that are watching, who would you point? Who would do really well with this?
I'd say it's for anyone who wants to get familiar with PyTorch. All you really need is some familiarity with Python programming. and a basic intuition of what happens in a neural network. Once you have that, it's really easy to relate the concepts in neural network theory or neural network training to the actual code if you follow along this guide. So the way the guide is structured is that there's an explanation and then there's a relevant code snippet that you can actually run in a Google Colab notebook as well.
Mm-hmm.
So you can instantly relate what you're reading to the actual code and see what the output is. And I feel like that just solidifies your understanding of what happens in a deep neural network.
Absolutely. Like I said, for me, the quick start that I like the most is it literally is end to end. Like if you know already what's going on, you literally just, here's the code, right?
Yeah, this page is specifically for people who are more familiar with deep learning. So for instance, maybe they have used deep learning in other frameworks and they just want to have a quick skim through what PyTorch does and how does it do it, what are the relevant submodules in PyTorch that do particular tasks.
Mm-hmm.
So this is a text light, code heavy sort of page where you get a whole snapshot of what's happening throughout the ML workflow in PyTorch in just a single web page.
And the cool thing is here, like if you look over here, let me do a little zoom it here. Oh, I need to move my mouse here. There you go. So if you do a little zoom it here, you're going to see like every section that one would need. Like you need to start with data. You need to make a model. You need to construct the model shape. Then you optimize the model parameters, and then you got to save it, and then you got to use it. And that's literally, I think, I mean, at least my opinion, this is all that needs to be done. This is like the whole process in a single nutshell, and you see how to do it with PyTorch every step of the way. And then you can dive in to understand each one of these concepts a little bit more. And that's my favorite part of this. All right. So thank you so much, Suraj. This has been awesome. For those that don't know, just go to pytorch.org and learn the basics in the tutorial. Thanks for watching, and we'll see you next time. All right. I think I did it right. Let me see. They wanted me to say something. Is there something I need to just say? Let me see. By the way, these things are so carefully crafted. Suraj is a professional. I think I got everything. Did we get everything, Suraj?
Yeah, I think so.
Yeah, I said everything. By the way, if I didn't say this, we collaborated with the folks at the PyTorch to do this. Suraj has been awesome to work with. So please feel free if you have any questions for Suraj to let us know. But now that I've got you here, can you hang out for like another 10 minutes and maybe look at my code and tell me where I suck?
Yeah,
or
yeah.
Tell me where. He's like, yeah, I'm going to jump on that right away. All right. So let's see what happened here. I'm trying to get my scoring thing working. Control Z. What the heck is going on? Oh, it's working now. I think what happened is it's not seeing the model file. So let's go here. By the way, let me review this. Let me go through this with you, and then you can tell me where to fix it. And then maybe I can have Dimitro come on later, like on another show, and then we can go through how to make my code better. But here is the training. There's the main, right? I have some transforms. There's my training data set. There is my validation data set. You notice and then my data loaders. Here's my model. Now, here's a question for you, Suraj, just out of curiosity. Is it better to describe models this way, or is it better to do it in a class? What do you think?
So in a class, the advantage is you have more fine-grained control on the parameters. Mm-hmm. You can also register various hooks into the execution of the model. So a really big advantage of PyTorch is that the models run dynamically. So every single iteration, there's a new computational graph that's created. And so the developer actually has freedom to manipulate very small, at a very fine-grained level. Like you can really interject execution, stop it for a bit, change something, and then continue. So classes are really helpful when you want to have more control on how the model executes. The way you have framed it, like within a sequential container, essentially it tells Torch to execute each of those models in the same order. So really, functionally, you are doing the same thing. you're calling the forward method on each of
I
these
see.
modules in the same order that they are declared over here. But you might not have as much control over the parameters from within this sequential container.
I see. So it's basically like putting them all in a list, but I can't like do hooks. I can't like inside of the class when it's running, I might be able to like do some special logging as it goes through each of the layers. Is that right?
Yeah, if you have a class, you can even have weights parameter sharing amongst all of these. So you can probably share weights
Oh,
between the first and the second linear layer if you had to.
so that's why you can save on space. I see. Okay, like let
You
me
can
understand.
have much more complicated architectures using a class, because then again, that class is a module that you can plug in anywhere else as well.
So here's a question from someone watching. This is Kevin Oliver. What is your opinion on PyTorch Lightning?
I think PyTorch Lightning, I haven't used it myself, but it really reduces a lot of the boilerplate that comes with writing deep learning software, and it's one step towards, I believe, leveling the playing field.
Yeah,
I personally haven't used the framework.
I looked at it. It's quite awesome. One of my colleagues, Ari, works with them now. And it's almost the difference between like driving a stick shift car and an automatic car. That's how I like to think about it. Sometimes you need fine-grained control when you're shifting, like if you're racing, you know what I'm saying, and you want to squeeze the most performance out of things, you go stick shift. But if you just want to get a model that's kind of tried and true, like I don't know, a convolutional neural network using MobileNet, like what I'm doing literally right here, this might be a better fit for PyTorch. I was thinking of going to PyTorch Lightning, but I wanted to squeeze the most out of it, and so currently I'm doing it in PyTorch. I might even try a PyTorch Lightning version. We can have Ari come on.
Yeah, I think that's a good next step. I know PyTorch Lightning also optimizes for distributed training and inference, and I think that's really interesting too.
By the way, the link for Learn the Basics, sorry, I got to fix my headphones. It's driving me crazy. aka.ms PyTorch Learn the Basics. We had a really good time putting this together, Suraj. Just want to let you know. Like, and notice that when you're looking at this, you're probably saying, oh, that looks familiar. It looks like Seth code. Well, because I wrote this part, and Suraj and Cassie, who led the efforts, put this all together in a nice way, right? Which was super, super nice. And this is what you're talking about when it comes to the class way of doing it, right?
That's exactly right. Yes.
So notice that I literally just did this because I'm lazy, I guess. But the reality is you can have self.linear1 and then say equal, right? And then you can pass IC. And then you could have each one of the things in here during the forward pass to do some cool stuff. Interesting. I like it.
Can I point out something in the API that I find very interesting? This is something that struck me when I was learning PyTorch and deep learning myself.
Okay.
And I like the way this API looks, because if you stretch your imagination a bit, the way this is laid out kind of looks like a neural network's structure by itself, you know?
It does. Let me bring it up so y'all can see, because I still have this thing over here. So let's put this over here. We'll put this over here. You can see that this is a cheaper version of that, but basically you would literally see 1, 2, 3 things, right? Because there's 3. There's a linear. I had to sneeze. Oh, I sneezed. Because we have like we wouldn't have all these batch norms and everything, but basically you would have linear, and that's it. You'd have 3 of them, and that's what it would look like, right? Which is really cool. But this is not the same model. Maybe we should run this. I don't know if we have enough time, but maybe we should have you come on and we should do another one where we like long form just run through all of this. What do you think? Like maybe in a couple weeks. Great.
Yeah.
Great to see you. Yeah. Thank you. By the way, when it comes to sneezing, I'm a pro. Just ask Suraj. He's like, let me take my sip. Let's take a sip of RT here. Okay. So that's cool. All right. So let's go back to my stuff. So that was the first question I had, but everything else seems pretty standard, right? Oh, here's what I did. Let me show you what I did, and I want to see what you think. So for training and for validation, I basically pass in the training and the validator, and I pass in an optimizer. But this runs through the whole epoch. And you can see that basically for the epoch, I just go through it. And then I'd go to a batch. And in the batch, you can see that if there is no optimizer, then I know it's set for validation. Oh, sorry. If the optimizer is there, I got to clear out the gradients. And then I set grad enabled to, if optimizer does not equal none, then I have to turn on gradients. I run the model, get the predictions, get the loss. If the optimizer is there, backwards, optimizer step, accuracy, return. So this is a batch.
Yeah, that's a smart way to do it because you're reducing the load on AutoGrad. You don't need AutoGrad to backpropagate your gradients if you're validating and not training. So that's a smart move.
And the other thing is, I can use this code for a validation and a training batch.
Yes.
Right?
Yep.
Because the accuracy is going to be the same either way, right? Accuracy is accuracy. The other thing that I realized that I did that maybe would be better if I did it in a class-based approach is I have logger. I'm doing some, what are these called? I forget what these are called. They're called, what? Do you know what these are called? I forget what these are called in Python.
The annotations?
Yes, not the annotations. It's like I forget what they're called. So lame. So basically I have a batch, I have an epoch call, and then I have a main call. And notice each of these have these things. I forget what they're called because I'm a goober. And notice what they really are is what PyTorch. No, they're called Python. They're not attributes. They're called attributes in C#. Decorators. They're decorators. They're decorators. Oh, thank you. Basically, it wraps the function, and I execute it, and then I'm doing some printing, right? So this is how I trap when I output. But you're saying is this is too much of a misdirection. Maybe just put it all in a class, right?
You could. This is not specific to the neural network itself. So you might not need to wrap this in the neural network class.
I see. So for logging and outputting, maybe have a full separation of concerns, and this is just a fine way to do it.
Yeah, I think so.
Okay. So he's okay with that because basically what's happening is when you run the model during the batch, and let me see if I'm understanding. It's basically this is literally just calling the forward function.
Yeah.
And then this is literally calling the backward function and the loss.
Yes.
Okay. Cool. All right. So let's see if I can get the scoring to work so that we can see it doing its thing. So let's close this. Let's go to the scoring. And I think I have a breakpoint. Let's F5 this thing. All right. Did someone say something on Learn TV? No, they have not. Okay. Hopefully it works now. Okay. Stuff is happening. The model is likely loading. That part takes a little bit of time. Oh, but this says tacos and burritos, so this is going to be wrong. I got to stop this because this is my old code. So now it's, I think it's, oh, crud. I don't know what the order is. How do you know what the order is? Let's see. So for us, it was, so here's a question, and this is hard for me. When I do an image folder, oh, here they are. These are the classes. These are the classes. I don't save the classes anywhere. Okay, I answered my own question. So basically, the image folder thing points at the training data, and basically the image folder knows to do that. There's going to be a none and a paper, rock, and scissors label. Is that right? It just does that for me automatically, and then that's where I get it. But what I need to do, I think, is on the outputs, I need to save the actual classes, right? Do you know what I'm saying, Suraj?
In the outputs, you need to save the actual classes.
Yeah, because like what's happening is when I score my thing, right, I need to know like is 0 none or is 0 rock, paper, scissors. You see what I'm saying?
Yeah, the encoding.
Yeah. So for those that don't know, the encoding, basically this this output right here, when I get an out, right? Basically, what's going to happen is this prediction is going to be like a vector of the size of the labels, and there's going to be numbers in here like N1, N2, all the way to how many labels there are, and the highest number is the one that is the prediction. But then we need to convert that into the actual label name, right? And so that's what I hadn't done. That's what I haven't done yet. So I gotta rewrite that part here in the last half hour. All right. Any other questions for Suraj? Well, we've got him, and I have some work to do. Or you can hang out and do work with me. But I'm a terrible coder, Suraj, as you're seeing here.
No, I don't really see that.
See, look at that. It's like, you know. It's like you get me, Suraj. But for some reason, I chose the ominous sad long strings. All right. So here's a question. I'm going to put it up there, but this is not like a schoolyard fight or anything. So there are differences between PyTorch over TensorFlow, and it's okay. Like you can choose the one that you like or you don't like. But if you could say, what are 3 things that make PyTorch stand out? Because obviously, like, look, some people ask me, like, well, why don't you use Google Foo? And I'm just like, look, I don't work for them, so I'm biased. So why am I going to give you an opinion that's biased? Instead, let me tell you what we're good at. So how about we do this, Suraj? If you could pick, like, the top couple of things that you absolutely love about PyTorch, what would they be?
What I really like about PyTorch is how the API is so Pythonic. Again, I had mentioned this before, that just using the PyTorch API really improved my understanding of some more complicated aspects of neural networks. You know, stuff like multitask learning, where the same data point teaches different things to the neural network. Like you give it an image, it understands color, it understands shape, it understands context, all from one data point. Mm-hmm. And the way the library is structured, it makes it very open to people who are not core programmers or computer scientists. And I think that's a really important or something to celebrate, really, because it results in the community being so diverse with so many different viewpoints on how something should be done. And I believe that's really that is the secret sauce, which is pushing the boundaries of deep learning every single day.
That's cool. Now I'm going to say it, but with some epic sound in the background. PyTorch.
That's the most compelling reason to use PyTorch.
I'm trying to make it so it doesn't. Let me do a low pass filter on that. There you go. Because you can do code the way you want. All right. Suraj, it's always a pleasure hanging out with you, bud. We should get you on again when I start refactoring. Maybe we could do like a refactor sesh, you know, when I finally make this code good. And that way it's like something that the PyTorch folks can be like, okay, you can go look at that now because it may work. Right. Anything final things to add? I'll put up the webpage here for a PyTorch. Any last things that you'd like to add? By the learn the basics here.
I just encourage anyone who might even have a passing interest in deep learning to not be intimidated by all of the stuff that you read about it. You know, it needs a lot of math. It needs a PhD to do this. That's not really true. Just get an intuition of it. Just get a sense of what's happening. You don't need to get into the math. Get a sense of that, and then head to learn the basics. And that should have you writing your own deep neural networks very soon, very quick.
I tried to play the good one, but it didn't work. I was supposed to do the clapping, but there you go. Thank you so much, Suraj. By the way, here's a from Drac. I'm a statistician learning to use PyTorch for biostats, and I'm trying to make a robot at home with face recognition, object detection, autonomous behavior. Holy cow, that's a lot. Drac, please make sure to ping us if you have any questions. We're pretty excited. From Mukund, that sounds really cool. Yeah, PyTorch is really cool. I started with TensorFlow at Microsoft. We have no dog in the fight, right? We don't care what you run on a cloud. In fact, the slower the better. That was a cloud joke, everybody. Just FYI. The slower the better. But I personally really like PyTorch because I was a programmer for a decade, C#, and then I went to grad school and did machine learning. And I find that PyTorch feels like it was written with Python in mind, with programming in mind, and with the way that I naturally think as a programmer. Now, TensorFlow might be nice for you. That's great. There's no hard feelings. Again, I don't care what you run on our cloud. The slower, the better. But as Suraj says, they work very hard to make sure PyTorch is awesome. From Kevin, very, very cool. Thanks, Suraj. I'm on a list to check out. Thank you, Suraj. From Aishagul. Wah, wah. Thanks so much for being with us, my friend. We'll see you next time.
Of course, I look forward to it.
All right, bud. Take care. All right. Maybe it's time to get to work. This time, friends, I have time. Like we have a half hour now. Remember before I used to end the stream and there was no more time to do the actual work? That ends now. I almost did it like Batman. That ends now. I feel like I could be like the guy that does like, voiceovers. Let's try one. In a world where you want to build deep learning programs, comes a library to help you do just that. PyTorch. Doesn't it feel like the beginning of a really good movie? PyTorch. Never again will you have to understand the intricacies of all of the math, but still have all of the power. PyTorch. Oh, I was personally moved by that. I don't know about y'all. And if you weren't, then maybe you should check your heart. I'm just kidding. Y'all are great. Love you guys. All right. Let's get back to work. Let's get back to work. Let's get back to work. I tried to push the button and it didn't work. Let's get back to work. Dang it. I think my my things wore off. Let me go back here. Let's get back to work. All right. Here we go. By the way, keep the comments coming. I enjoy talking with you all. And literally, this is like my brain when I'm coding. I'm like thinking like 7 different things, and there's weird music in the background. Sometimes some extra voices. I don't know where they're coming from. All right, so what we're going to do is we're going to try scoring, but I remembered that I did not output. So let's see. So first of all, let's see. Okay. So source outputs model.onyx. So let's make sure this is loaded properly. So let's F5 this. F5 this. By the way, we're trying to see if this model works. Basically, is what we're trying to do. So we F5 this. Things are happening. Did I already pass the breakpoint? No, let's go over it. Maybe I already passed the breakpoint. Here we go. Okay, so here is the problem. Oh, this is on purpose. So the model path is output. Okay, these are the classes. They're wrong, so we'll have to redo that. We load up the inference session. This is the input name, input.1. These are the transforms. Okay, now it's time to do the rock. So F11. here's the raw data, right? Image. And by the way, remember we are running this right here. So there you go. F10, F10, F10. So we're getting the image. Oh, Control Z. So we got the image. There's the response. We're going to open the image using Pillow. There's the image in bits. Do you see that? We're going to transform the image. And then what we're going to do is we're going to unsqueeze this vector, right? So this is basically a huge vector, right? It's a tensor. You can see all the numbers in there. This is what the actual picture is after we've, moved everything, all the pixels around. Because remember, part of the transformation was to normalize the pixels. Because if the numbers are too big, because the numbers are between 0 and 255, what this does is it normalizes them. Like, it centers them. I don't know where these numbers come from. I just copied them off of the PyTorch website. If I'm being honest, we could probably train a neural network or something to learn the proper ones of these. And then it does a prediction. So this was a rock. And notice that the answers that come out is this, right? And so it's not super confident on what it is, but it thinks that the answer is answer 3. Now, the problem with this is that I don't know what 3 is because I did not output the classes. So what I'm going to have to do is I'm going to have to retrain this thing. What I'll do is I'll do this. I'll retrain it. I'll just save the classes out. That's what I'll do. I'll save the classes out. So let's stop this. Very nice. Let's go to the training. And what I'll do is let's do this. So classes, JSON dot dump. Oh geez, we don't have JSON up here. Import JSON. Okay. JSON. I don't know why this is weird. It's like literally right next to you. What's your problem? The JSON. All right. So we go down here, and what we're gonna do is we're gonna dump this out. JSON.dumps. Is it dumps? And then we're gonna say, let's make a new dictionary, and let's just say classes. Let's do this. Classes, and then we're gonna have to do something like with open, and then let's see, we're gonna go .. and then outputs we'll say this is the model .meta model.meta, right? And then we're gonna write to it. So write as F. And then what we are going to do is move this like this. This is from my JavaScript programming. I don't need to do that because this is Python. And I think, let's see, JSON.dumps. If skip keys, blah, blah, blah. Let's see. And then we're going to say indent. I think it's, let's do 4 here. I think it's JSON.dump. And then we're going to say f.write this. I think this will work. So let's pause it right here and let's F5 this. Because remember, just for context, when I run this, it's going to give me the max index is the thing that's right, but I don't know what the max index corresponds to because the max index comes from these classes things. So let's run this. F5 here. By the way, Suraj was talking about like print statements. In Visual Studio Code, you can literally debug it. With static graph style things, it's kind of hard to do that. So F10, there we go. There's model.meta. Bam! Bam! Those are our classes. In here, we can also put other things about the model so that the model actually becomes like, for example, you can put in like a lot of attributes to the model. Like it expects channels first when it comes to the images and the size, and even maybe a description of the transformation so that the model becomes like a description. You know, I'm having an idea here. It would be nice if we had a common way to describe the API or the entry point of a machine learning model. I know that in Onyx it has a way to do it, but not everyone agrees for other things. There's a lot of people that use Onyx format, but okay. So we know now, let me stop this. We know now that this is 0, this is 1, this is 2, this is 3. And so when we go to the score, let's remind ourselves what it's guessing. You know what? We can actually, let's do this. This is, we can ignore for now. But what we can do is we can say model path is this. And then what we can do is we can say os.path. Oh, wait a minute. I don't have OS up in here. Import OS, right? I can say os.path.join, and then I can say model path, and then comma model.onyx, boom, boom, boom. And then what we can do is we can add another thing. Oh, classes. It's there. Nice. And what we can do is we can actually load it. So we can say metadata, model meta equals model meta equals that bothers me. We can say JSON.loads, and we can literally put the file name in there, which would be the os.path.join, boop, and that's going to be the model path, boom, and then we can say model.meta. This will be a dictionary. Oops. This will be a dictionary, and in the dictionary we want the classes. We want the classes from that. So the classes are actually going to be model meta classes. Boom. Okay. This should work. This should work. No, I just made that extension up because why not? So let's F5 this. By the way, I think it's going to get it wrong. Because you could see that there wasn't a lot of volume inside of the... Or maybe it gets it right. I don't know. Okay, running. That's good. It's supposed to fail. So model... Oh, jeez. What's the problem? JSON decode error. Expecting value. Let's see here. Model meta. What is it expecting? Why are you doing this to me? Oh! Like, this is the yak shaving part of programming that I can't stand. Ugh. Okay, let me close the file. Here, let's stop this. Let me close the file because as if that has anything to do with it. So outputs, model meta. Let's do this. Let's do this. And let's see, JSON.loads. Deserializes. Oh, I see. I think it's this. Oh, I know what it is. I'm an idiot. Okay. With open meta file, comma, we want only read as F, then we can do this. I think it's loads. All right, let's try that again. That was embarrassing. Yeah, look, I have to Google with Bing how to open files literally like 6 times in a day. Ugh. Take a sip here first. Okay. F10. F10. Oh my gosh. What? I think it's load. Stop it. Okay, F5. Do this again. We're gonna have to Google this with Bing, aren't we? How embarrassing. It's okay. It's not like there's people watching. Let's just make sure the file's in the right place. Yeah. I know. He's like, you should just Google it. I know. But you know how we are. You know how us programmers are. We're like, no, we can figure it out. Just like I did. What up? What's up? We did it. There's the classes, right? Let's go to F5 again. Okay, so it's going to load the image. By the way, you can see here. Here. There it is. Do you see that? I got it. Get the image. Notice that it's this ugly thing. We're going to transform it. Now what we got is we got our tensor. Kapow! Tensor. I'll put this back over here. By the way, I almost did. I was like, if that didn't work, we were going to Google it with Bing. And now we run it. Boop. And there is a prediction. Okay. So it looks like the max index is 3. So then we do this. By the way, this is just to keep track. So there's the length of classes. Very good. There's the predictions. And then I get the thing. Continue. This is the payload. So it's predicting scissors. It got it wrong. And then these are the scores. Okay, F5. F5. Okay. So now you know, well, it got it wrong, by the way, but that's neither here nor there. We need to make a better model. I think the best model we had, we should do like a ResNet or something, but the best model we had got like 86% on the validation or the training data. So we'll retrain it and see what happens. So yeah, that's it. Notice that we've figured out how to train things and how to score things. So what I'm going to do is I am going to fix this because these I don't like. These models all suck. And by the way, now we're getting into the real yak shaving of data science. And what we're going to need to do is we're going to need to retrain this. We're going to need to retrain this with something else. We did fix this this problem, right? This problem was, and we could probably in this we could probably have a dictionary that we store that saves a bunch of stuff like how well it did, how smart it was, etc. And then like for the best model, there would be like a model.meta, and then the model itself would be the model file, the Onyx file, and then the meta file. But let's build this again. But let's just I don't know. MobileNet is not working. So let's do this. Models. What else we got for transfer learning? Models. Dot. Oh, it's not gonna know, is it? Oh my gosh. Come on. Models. Dot. Do a ResNet 50. I don't know why it's not seeing it, but let's do this. Let's just run it here. And let me make sure what the default values are here. So this is working. This is working. So the data folder is right. So we'll just leave that. Because it goes for the train and the val. That's right. And then the outputs goes into dot outputs. Correcto. 15 epochs. Batch size of 4. I wonder. Let's do a better batch size here. And let's start with a bigger learning rate. I guess I could pass these in. By the way, let's do 25 because it saves them as it goes. So if I stop it, it doesn't matter. You should. He's saying you should pre-train with the new Vision ResNet 50. I haven't heard of it. Is it in? Does PyTorch have it? So for those who don't know, basically, this is like hacky cheating. It's not cheating, but basically, someone has built really deep neural networks that are good at some things, and I basically put it's like I take the long part and I hack the rest off, and then I put my bits in there, right? And so it's like I'm building on top of a neural network already. I haven't heard of the new Vision ResNet 50. Is it inside of PyTorch? Let me see here. Models. So here are the ones that I can do. There's AlexNet. There's DenseNet 121. There's DenseNet blah, blah, blah. There's GoogleNet, Inception v3. And to be fair, I think I'm on PyTorch 1.7 because we haven't changed it. There's a ResNet 101, ResNet 18, ResNet 50, ResNet 50, blah, 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 blah. Oh, so Kevin's saying not built in. You have to pip install Microsoft Vision. Oh, I didn't know that, Kevin. We should chat, man. Email me or ping or tweet at me. Tweet, do the tweets. Looking at the GitHub, there are some specifics you need. You can't drop in the link. So maybe just a ResNet 50. Okay, we'll do ResNet 50, but then we should chat because I got 10 minutes, you know. Let's try it. We're doing cross entropy loss, and I'm doing an LR back off at step size equals 7. Let's back off a little bit faster at 5, and then we'll leave the gamma set to 0.1. All right, so everyone's looking at this like, what the freak is all this? Maybe next time I'll do let's really dive into what's going on. Imagine like instead of like writing a function with stuff, you're like, okay, I'm allowed myself 500 if statements and 200 for loops, and that's all I can use to make this. And then computer, you figure out like how to weight each of these if statements and for loops. That's basically what we're doing. And then it figures it out, right? But you have to tell it like the shape. Like it doesn't learn functions on its own. You have to give it a shape. And this is the shape that we're giving it. This is the function that we're going to use to make the predictions. And the input is the image resized and normalized. And the output is a vector of size 4. Okay, I think we got this. So Control S here. Now get ready to warm yourselves by the fires of my GPU. Here we go. Notice here, it tells me what Conda environment I'm in. What's going on here? Oh, this is AML stuff. I'll get into this later. But notice that here is all the stuff that's coming in. Here is the actual model. You can see that the sequential model has a ResNet built in, and the ResNet is long. Oh, geez. Is it going to do this every time? Okay, I'm going to stop this. Let's take that off. This is for logging, but I just need to stop it. It's like not working all the way. I think I broke my Azure machine learning code the other day. So let's just take that out so that we're not having this issue. We're just going to take that out. No need it. That was dumb. I can just say if false. I know. We can take this off. Boop, boop, boop. If. By the way, I'll talk about this later on. Basically, there's a way to log these things. It makes it easier. If run offline. This should have been none. So let's just. This is pachucho, as we would say in southern Spain. Que pachucho. And we'll just say run equals a none. Okay. All right, let's try again. We got 8 minutes to. By the way, Learn TV will shut us down at exactly 1 p.m. FYI. What is it talking about? What is it still doing? Okay, here we go. Here we go. Now it's learning. Let me make sure there's. Let me see if there's any questions here on Learn TV. Nope. Yeah, why is it doing this? Come on. Ooh. Why is it doing this? Okay, let me fix this. This is making me cranky. Let's go to the training here. Okay. Now let's go to helpers and let's just find run. Here. If run does not equal none, it's none. Okay. If run does not equal none, if run does not equal none. Okay, run equals none. Let's take this out. Let's just take this out. It's just making me cranky. Okay, now let's go down and let's take all of these out. Boom. We don't need this. We'll fix this later. Oh, jeez. Don't you hate it when stuff is like, and you got like 6 minutes left? Okay. We don't need any of this. This is all. No. We don't need that. And we don't need this. This we can take out. Okay. By the way, this is the kind of stuff we could put into our other thing. Okay. Last time, CLS, because I don't want that error stuff coming at us. All right, we're training this. Here we go. Building model, transfer learning. It says MobileNet, but it means ResNet. I just didn't output the right thing. The learning rate starting at 0.01, so we can go super fast at the beginning, and then we'll step, exponentially down. So we'll go to 0.001. Okay, here we go. Now it's doing a thing. We are wrapping in 5 minutes. They're telling me, oh my goodness, what terrible accuracy to start. And then hopefully it gets better, right? So it found a better model. By the way, notice that now on the outputs, the model meta is there. You can see it's there as well because it just wrote that out. All right. So this is going. We have about 5 minutes. Let's get all your questions in. I know some of you are watching, because this is the boring part where it's learning stuff. Okay, so let's see the improvement. Yeah, that's a pretty significant improvement. 40 to 50. So hopefully it, by the way, notice that what it's doing is it's saving the Onyx and the PyTorch model. And then if it finds one with better accuracy on the validation set, it basically just saves that one as the official one is what it's doing. But there's smarter things you can do. All right, so questions from the audience. So we got about 4 minutes left before they kick us off. What do you got for me, my friends? Oh, look at that. It's getting a lot smarter. This is already better than... this is already way better than the other thing. Wow, that's cool. Notice it's because the learning rate is so high. But it's going to start slowing down because the thing is, we want it to get smarter, but then if we shoot too far, it added 10 points there. That's awesome. I think on the next epoch, it's going to go to 0.001 or the one after that because I set it to 5. No, yeah, I think I do a +1 on the epoch. So in theory, at the next one, the learning rate should go to 0.001. It might be that on the MobileNet, my learning rate was just bad. Yeah, so Kevin's asking about MLflow. Absolutely. Right now, we're just doing the garbage work, and then we're going to start to clean this up a lot. Yeah, MLflow absolutely would be an awesome way to log this stuff. Okay, look at that. Do you see that? The learning rate now stepped down because we're getting close to stuff. Notice that we increased by only 1 point here, which means that we may have overshot. And now if we make the learning rate smaller, we can start to go down what's going on. And so we only have like 3 minutes left. So I'm going to let it do like another epoch. And then in the meantime, what I'm going to do is I'm going to do a scoring thing. So let that. Yeah, notice. See, it's not getting any smarter. Maybe the learning rate is too small. Maybe I should continue on the learning rate being that big. Okay, so let's go over here and let's CD Rochambeau, CD SRC, Conda activate torch. Okay, and in between epochs, I'm going to do now a Python score. And remember that we actually gave it a rock. Here we go. By the way, my GPU is very upset with me right now. It's like burning my hand. Inference with rock. Look at that. Look at that. It's already getting smarter. Do you see that? It's already getting smarter. What was the other one? Did I put a scissors in there? Let's look on the eval. Let's do a paper. Look at that, already getting smarter. Let's give it a paper. All right. My friends, come on, before we run out of time. By the way, for next time, you're just going to have to guess if it's got it. Did it get it right? Inference with paper? Did it get it right? Paper! By the way, next time, I'm super excited to tell you about, let's finish up today. Say thank you all for being here. And what we're going to do is I'm going to put the banner up for the next show that's coming in the future. Thanks for watching. We'll see you next time.
I think everyone wonders what they would do if they saw a ghost. I'm not afraid of your ghost, Suraj. I think everyone wonders what you would